So hi everyone, my name is Jack. I'm a Apache Iceberg PSP member and also work for LanceDB as a software engineer. So today I'm going to talk about connecting to a Lance namespace through Iceberg REST catalog. So I guess before I start, thanks Jason for presenting my talk during the keynote. And if you're interested in vector search or multimodal data, this is the talk for you. So the agenda today is that I'm first going to go through my personal journey for trying to push for multi-format IRC, Iceberg REST catalog, the whole journey of that. And what I have learned, what was successful, what was not successful, and how I use that to come up with what is we call Lance namespace, and how that can integrate with IRC, the whole architecture of that. And then in the end, I'm going to talk about the next steps about what it will look like in the future. So first of all, the journey of, well, I say journey because it is really a multi-year thing. It kind of started in 2022 when I was still in Amazon in EMR and Athena. We had this problem that we have many different formats we want to support: Iceberg, Hoodie, Delta, Hive, and all the file formats in Hive. And each of them has a different connector. And it has been a very operational hell to maintain all those connectors. And this was kind of my vision, which is we have Iceberg REST catalog that was being developed at that time. And it would be nice that we know our investment is in Iceberg, so we will continue to put the Iceberg connector, but at the same time, it can also read all the other formats so that we can keep the investment in a single connector, make that stronger and better, and also make that interoperable through the IRC layer. And throughout the years, I think we made a few successful things. The first one is we were able to let our customers read Hive tables through IRC. We kind of pushed a few APIs in the Iceberg REST catalog stack, and we did POCs with some important customers, and you can actually express Hive tables and read that through IRC. Last year, we also launched SageMaker Lakehouse, which is actually reading Redshift tables through IRC. Kind of the same idea. The only difference is that there's a Redshift engine behind the scenes so that you are actually generating Parquet files on the fly. So you are not just replicating the metadata and representing that in Iceberg. You are also representing data in the Iceberg shape. And that gives you connectivity to Redshift and also all kinds of non-accessible data sources that you can achieve. So there are a few things that we have kind of learned throughout this whole process. The first thing is that actually, the performance is not that ideal. I guess this is more like a trade-off because you are trading off the generalized accessibility with more specialized performance characteristics. So it was kind of okay to read Parquet-based formats like Hive, Delta, or Hoodie. For Hive, it's actually working very well. But if you are working with like Delta or Hoodie, then you kind of lost some optimizations that are native to the format. And if the data is not in Parquet, then the so-called runtime ETL to generate the Parquet file on the fly is, of course, going to be slow in the first run. It is kind of cached in the second run, but in the initial execution, it's still pretty slow. So we did the acceleration when we launched SageMaker Lakehouse, which is we did this thing called the Glue Iceberg Spark extension, so that because our focus was on the Spark engine, then we did the specialized optimization rules in Spark to say that actually you can do not just at the scan node level, but you can push a larger query plan into Redshift so that you can return that data. But that is still kind of not ideal. It works good for like dashboard use cases, but it is not always working when you have to unload a large data. There are also some ideas that can compensate for this. For example, Microsoft Fabric, what it did is that you have a centralized planning component and you can send any query plan, translate that into substrate, and then the planner node does optimizations and send that plan back and does some executions. But that only works kind of in Fabric. There are some open source solutions to that. For example, what I was pushing later was like an MV-based query rewrite so that you can do on-the-fly MV generation, and the MV will be able to push down whatever query you can have instead of just a scan node in Iceberg. And also there's the multi-file format proposal in Iceberg that if we can support the multiple file formats, then you are not just bonded to Parquet. I guess it's Parquet.org, but mostly Parquet. So you are not just bonded to those three formats. If the underlying data source has a different format, then you can just implement a plugin and everything still works. But these two like open source things are more on the early stage. And that kind of leads to the second landing, which is the whole idea, I think even today is not really the mainstream, but also it is actually becoming more mainstream as we are developing projects like Polaris, Gravitino, and Unity. So over the past 3 years, it's almost like there was an idea that this is more of an experimental feature, and Iceberg REST catalog is more for Iceberg tables. For the whole thing I was just talking about, the proposal I put up was in 2023, and then we get the spec merged in 2024. And even today, we are still working on the Java client-side integration. There are 2 PRs, the previous one from Rahil, which was an engineer from AWS, and now I think Snowflake is picking that up. Prashant is having a new PR to get this, carry on this work. And after this, there's still the engine integrations, there's still Python integration, Rust. You have to then spread all the integration around all these ecosystems. So it is actually a pretty slow process to get things done in this direction. And when I was evaluating why, I think overall the architecture works from organization perspective that we want to reduce operation to maintain many connectors. We want to centralize governance. We want to generalize connectives through a single connector. But on the other side, it becomes a trade-off that in the open source, all the features you want to push depends on making the Iceberg REST catalog more complex, and also making the Iceberg connector having to integrate with these complex features in the catalog. And I say the investment is not aligned because typically catalog is not the organization that is making money, right? The one that is making money is the connector, is the engine. So you don't really have as enough people to work on these catalog features, comparing to people who are on the engine team and have very strong motivation to do optimizations, to build native engines to make that better. So, and on the other side, when trying to push these kind of things, it becomes a time-consuming consensus-making process because most of the Iceberg people are Iceberg experts, but not really in like Delta, Hoodie, Python, all these new formats. And becomes very hard, like a consensus-making process to say, okay, I need to understand your requirement, and then we will see if that works in Iceberg, and so on and so forth. And it becomes very hard to add specialized features. So it's kind of like, oh, we want to always merge a PR in Iceberg, and then it comes back with that it has nothing to do with Iceberg, then it goes back and forth, right? And as I was moving to LansDB, I feel this is becoming especially true because, for example, for Lans, it is specialized for quite a few unique features that which only make sense for very specific formats and only make sense for Lans, maybe not that much for the other formats. And if you don't know Lans, this might be a good introduction for the features. The first one is, for example, multimodal, that the Lans format itself is built for like image, video, embeddings, all these ML, AI, stuffs. And the file format itself is actually optimized for those use cases. Unlike Parquet, you have row groups. This thing doesn't actually have row groups, and you are able to drop whatever videos, images, blobs into the file without compensating much for the performance with other columns. And it becomes very hard to reconcile. For example, we want to add an image row or image data type or video data type. It just doesn't make much sense. And another thing, which is random access, which is important for workflows in ML AI, like random sampling, vector search, full text search. And this is done by mainly through different kind of indexes that Lans has. But when we try to reconcile that with, for example, Iceberg, then it becomes kind of hard to say that, okay, Iceberg, it's kind of written on the title that it is a slowly changing format for analytic data. And but this is really tapping into kind of the OLTP domain that you want to have random access in a very efficient way. And we have different indices for different purposes. And if we want to reconcile that into the connector, it will be a very hard effort to do. And the other thing is data evolution, which is instead of just schema evolution, and also you are appending data I guess vertically to add more rows, you can actually add horizontally different kind of columns into the Lans data set. And this is a really different design from all the other existing table formats today because, for example, given idea, this is a customer that LansDB has called WordLab, which is founded by Fei Li, who is professor in Stanford, a pretty famous ML AI world. For example, there's this workflow about I have starting with a bunch of images, right? And then I run through different LLM models to generate different embeddings. And then from those embeddings, I can generate different tags and go on, so on and so forth. I can have columns, generating columns, forming a kind of very rich feature store and run that through the multimodal AI stuff. And in Lens, that is pretty easy to do because Lens has fragments, and fragments has different files representing different columns. But how do I reconcile that into Iceberg? It is actually pretty difficult. And maybe we will need to add different Spark optimizer rules to support this kind of workloads. But does that really make sense to do that? So all these kind of things made me trigger to say that actually looking into the industry, while we are kind of trying to push interoperability within IRC, there are already kind of projects that are doing something kind of different, such as Unity and Gravitino. Because instead of this multi-format Iceberg vision, what these new projects, well, they are not so new as I'm talking right now, but these projects, I think this is how I draw those diagrams, which is you have very different connectors that are talking to the catalog servers. A server exposes different APIs, right? It can be HMS APIs for different like Hudi, Pymon, Hive, and Delta connectors. And you have IRC APIs that is for Iceberg. And then you can connect to, for whatever engine, if you have a connector, you can connect through those open source APIs. And then those connectors directly then talk back to the storage so that you have very organized integration through different connectors. And that mode seems to be working much better comparing to having a single connector encapsulating all the features of the same storage. One thing I didn't put in this diagram is that for these projects, there are also what I call a meta connector that you can do like routings to internally to different connectors behind the scene. For example, I think for Unity, it's called UC single catalog. And for Gravitino, there's like a driver plugin to connect your catalog managers and route to different connectors. Right, but I think those are kind of just user experience improvements. But under the hood, I think this is the spirit of what I think is good. And summarizing that, for the performance, really comparing to the original approach, you don't have data exchange. For example, the ones that we did in Redshift, and also the format is using the native connector to get best performance. And the catalogs are naturally multi-format. And for the feature development, from the open source perspective, the different communities are maintaining different specialized connectors, and they will naturally prioritize for the specific use cases to make that better. And they are not blocked by other communities to do the same thing, right? But as I said, it is a trade-off of open source versus like typical corporate organizational priority that is landed in these two different architecture choices. So does that mean that the vision is kind of dead? Like now we have Unity and Gravitino, but which I don't think so, because I think there's a good way to actually combine those two into a unified structure that that I call kind of like a vision V2, right? Because instead of saying that some like you have to have different connectors to work with different formats, or you versus you have a single connector that can connect to different formats in an interruptible way. You can actually have both, right? So the Iceberg connector could serve as a baseline for accessing whatever data source through the table planning APIs, through whatever RAD APIs we're going to build later. But on the other side, if you want to specialize connections, you can always go through the specialized connector. And all that need is the IRC API to be able to store those tables. And you don't need to actually cost much to store those tables, because you just need a definition, right? And the definition for most of the other tables, other than Iceberg, interestingly, is that most of these tables just need a table name and a location and nothing else, right? And the connector will go to the location to find the other metadata. So I was like, okay, let's experiment with Lens. And coincidentally, there was exactly this requirement from ByteDance, who is actually the main maintainer of the Lens Spark connector, to say that we need kind of this feature. So we did what we call Lens Namespace, which is kind of an open, it's a spec on top of the existing Lens data format to standardize access to a collection of Lens tables. So kind of just give a background about before the Lens Namespace. The way we integrate it in the Lens world is that there's a directory and there's a directory of Lens tables. And for the enterprise thing, there's more complicated remote database, but that also just has a list of tables. And if you are using Spark, you just configure the Spark catalog implementation of Lens, and then you say a path, and that path points to your kind of directory. And you kind of just have a single default namespace, which is default, and then you select tables in that. And And it was like, I was actually surprised when I chose LanceDB that does that really work? Because, but actually it works for most ML AI engineers that are working with directories. But I think we can do better, right? We can have better catalog integrations. So when we are designing the Lance namespace thing, we did a lot of learnings from the Iceberg journey. So not just IRC, but beginning from when we are designing the Iceberg Java catalog interface to all the experience we had in doing the IRC. So the first thing is we realized that we really like the multi-namespace concept because it can adapt to any kind of implementation of the server backend. However, for Lance specifically, if we keep the catalog concept, then you have to have 3 layers, right? But then how do we support this? I just have a directory of tables. Then we were like, okay, then let's just remove the catalog concept at all, because these are really just containers of different names like catalog, metastore, schema database, or meta lake. These are just containers. So let's just call them all namespace. That's why the name nice namespace. And then another thing we really like about IRC is the standardizations through a JSON schema in Open API. And so we also follow that. So there's an Open API definition for all the requests and responses. However, we are not really using the REST path because we are kind of learning from other protocols in the AI world like MCP, A2A, that you can just define the request and response, and then you can send with all the post APIs. And so there you all see like post list namespaces with list namespace request and return response. So that makes the REST API not really REST. If you are REST, if you are a super strict person about REST, you might not be happy about this. But this is what we come up with, and also we directly use a CodeGen to do the language integrations instead of in Iceberg, because Iceberg started with Java. So there's like a Java interface, Java POJO, and then it maps to the REST. So this is directly skipping that level to directly use a CodeGen. And we want to really balance the implementation between the custom implementation versus a standardization in REST. Because in the Iceberg case, one of the biggest reasons for doing REST is about standardization, because there's a proliferation of different implementations of Iceberg catalog. Blue one, the Snowflake one, all different vendors are implementing a catalog implementation for Iceberg, and that gets kind of out of control. Versus the REST standardization. But we all know that this is really a trade-off because once you have standardization, then you are adding additional hops into, if you are just doing adapter of your internal catalog thing, then you are kind of adding another layer in between. So there are pros and cons, and we kind of want to bake that into the stack that you need to understand the pros and cons, and you can choose which one you go. So today there is an implementation for directories, there is an implementation for HMS, there's the IRC implementation I'm going to talk about later, and versus there's a REST implementation. So there are all those 4 implementations there. And also we added the concept of managed by, it's actually a table, it's managed by the names implementation versus storage. So we have the concept about if the catalog is managing the version of the table versus if the storage is the source of truth about the version, because there's a difference between Iceberg, who is always having the latest version in the catalog, versus all the other formats are actually resolving the version in the storage. So we want to make a consistent experience to say that either the namespace is managing the version or either the storage is managing that. So after the namespace work, so you can actually define the type of the namespace, and then you can point to the URL REST, and then you can do reference just like you are referencing any traditional data warehouse tables using standard delimiter kind of conventions, identifier conventions. So how does it integrate with IRC? That is the key part. So first of all, we want to pick a IRC server. I always go to Gravitino because it's actually a very easy choice to set up things, especially for a person like me who has implemented like 4 different catalog implementations in Iceberg. I just implement another implementation and then I just plug into Gravitino and everything works. So essentially I kind of bake the idea, the logic I'm going to talk about later into this implementation, which I call Lance-Aware. I use JDBC, so a Lance-Aware JDBC catalog. And then the IRC will redirect all the traffic to use my logic to serve data, serve metadata to the client. So now what we need to do is really, we want a table object in the IRC so that it is actually pointing to a lens table, and we know it is a lens table. And we want to be able to create the table, and also we want to be able to load the table. So the logic of that is essentially when you do rc.create table, you I can specify a table format property, and that property is equal to lens. And with that logic in the backend, the implementation will say that, okay, I see that this format is equal to lens, so I will run the lens logic instead of the Iceberg logic to write the table. And also we are passing the schema, and because lens uses arrow schema, so it's pretty easy that I'm just converting Iceberg schema to the arrow schema to be able to create the lens table. And when I do the load table, it's kind of the reverse. So basically, the IRC needs to really just surface three informations. The first one is, well, four informations technically. The name of the table, the location of the table, and if it is managed by catalog or the storage. And if it is managed by the catalogs, then tell me which version of the table to load, right? And with those four informations, the backend implementation is able to essentially load the table back into, the client, after knowing those informations, will be able to process the request just like it is a lens table and take over from there. So going then one level above that. So as I said, there's IRC implementation for the lens namespace, so that when I do a lens namespace called create table, it will invoke the IRC logic and then give back the information I was talking about. And then when I do create table, it will call the IRC create table with the information I was talking about, so that it kind of completes the whole cycle. And in the end, all the essentially with this, all the lens connectors that work with lens namespace will be able to work with a lens table in IRC. So we get all the ML toolings like PyTorch, TensorFlow, and all the LLM tools, all the embedding libraries, OpenAI, Amazon Bedrock, all these kind of things will work out of the box with this kind of integration. So you literally have a lens table sitting in your IRC, and you are able to connect it with whatever connector that lens supports. So the next step is that, of course, we want to finish our implementation of the lens namespace. It currently just sits in my personal branch. But it is a very early project, and we are still finalizing actually the lens names stack also with different people in different communities, in different companies in this community, I mean. And we want to finish the integration of that and just essentially just spread out this integration with everything that works in lens. And on the other side, we are also thinking about doing the integration with Unity and Gravity to start with, so that we can get this end-to-end thing working officially in these two projects. Interestingly, I was talking to Yukui from Snowflake just now that they did a very similar thing for supporting Delta Lake table in IRC. So I think I'm actually very excited now to see how that works. I think we can actually also make that work in Polaris to make exactly this workflow with IRC working in the setup. Okay, so that's kind of the end of the talk. If you are interested in Lens, give us a star on LensDB, Lens, or Lens namespace. We also have different projects for like Spark, Flink, Trino, Presto, all these projects are there. We really appreciate discussing and contributions to the project. Yeah, thank you.
Thank you, Jack. Q&A, any questions? Please feel free. Lisa, I know you have one.
Thanks so much. This is very timely for folks like us who are building Iceberg and Lance as sort of a vector, open vector lakehouse. So for a user like me, when can I look at a Lance table, something like AWS Glue?
I think that's a great question. In this kind of architecture, you kind of the IRC implementation needs to support storing this kind of things. That's why I was saying that in Polaris, we are we are probably able to do the integration because that is open source project, and we can just go there and make the code change. Comparing to a vendor product like AWS Glue, then that's product feature request to the Glue team. Well, there are potential hacks maybe you can do to say that actually I will create like a dual table, right? So there's a lens table and then Iceberg table sitting in the same directory. That actually works. And then you can actually get the location information, especially when it's managed by storage. Then you can get the location information from the storage, and then that dummy Iceberg table's job is done, then you can go there with lens. So that is potentially one workaround that you can do. Yeah, now I think about that.
Hi. So there are some differences between Iceberg and Lance, especially like partitioning. Iceberg has versus Lance is different way of doing it, as well as how do you handle indexing in Lance, which is not there in Iceberg.
Oh, sorry, I think, is that a question? Or?
So yeah, the question is, how do you handle those things?
Handle
partitioning, indexing.
Handle in like this architecture? I think this architecture is really promoting the concept that you let the community who is working on that to do the right thing, right? So that the catalog is really holding a pointer to the lens table and how the table is maintained, how that is read or write, read or written is really done by whatever tooling that community offers, right? So that the catalog is not in the way, and the Iceberg connector is not necessarily in the way about to block you from doing anything, because you are free to do whatever tooling that is suitable for the community, right? And in the lens case, if you want to do vector search, you use the lens connector to do vector search, but the table can still be in Iceberg in ERC, right?
Good.
Thank you for the incredible talk. We didn't pay you, by the way, to mention Gravitino, although I wish you did. So one of the things that I'm really curious about, and obviously because I'm from the Gravitino side, I want to get your opinion on this, but what is sort of the biggest mistake that you think the catalog creators will make or can make that would prevent, let's say, this open ecosystem from truly meeting its full potential? Or whether it's Unity, whether it's Gravitino, et cetera, because I think one of the issues with catalogs is the scope creep, right? All of a sudden it touches everything and becomes this really heavy, big, piece of your architecture, and it can actually get quite messy when working with multiple namespaces like this.
Well, that's a very broad question. I think my personal stance is that currently we are drawing a line between catalog and storage. And that line has been very blurred recently, because I feel we are going back and forth with whatever direction we go, right? We started with Hive Metastore, and we feel that has becoming too fat. And then we put all the metadata in S3, and everyone is happy. And then we have IRC that is trying to kind of lift back some metadata into the catalog. And we think that this time we'll do it right? But is that always going to be right? Maybe not. So I would imagine this is like history always repeating itself, right? And we see that in all different places. So I think I won't say like big mistake. Like it is an exploration process. You need to get a few cycles to get things right, and eventually we'll land somewhere in the middle, right? That I think I'm expecting that to be the end state. That somewhere in the middle we'll find a balance between what is in catalog, what is in storage, and then everyone is happy about that, and we move forward with different requests. For example, now in the AI hype, in the AI wave, people want to move faster. In this case, then we put more metadata in storage that we have more control of, and when things get settled down a bit, maybe it will lift it up again. So I think it will always go back and forth. Yeah.
Okay. Oh, one more.
I have a question. Like, in the example, you shows like you create a lens table, and then my question is, does it support like if we have an existing Iceberg table, then can we have a lens table on top of it, or like if someone has a QD table, existing QD table, and then create a lens table on it, and then use IRC to query it? And my second question is, so when getting the table, looks like it need to convert the lens table into Iceberg table and then return to the response. How is the performance like?
I mean, this is just the metadata path, right? So typically that is that is not a critical path of the query. I guess I'm answering your second question first. So, and if you are concerned about performance, then that's actually one thing about either you want to use a implementation versus a kind of like a REST-based solution, that you always get better performance if you are directly going with implementation that is hitting directly your backend, right? So that is one thing to consider. And going back to the kind of the dual table scenario, I think that depends on the format, because some format doesn't really allow other things in the table or in the directory at the storage layer. And if you put other things, then it messes things up. So it has to be analyzed like case by case.
We'll take one more question.
Hey, Jack. Thanks for the talk. So one curious question is the catalog that you're exposing these LANs tables as Iceberg tables. Are you also extending the results behind the pre-planned plan interface? Like I can actually query those LANs tables from any 3P engine using off-the-shelf Iceberg connector?
That's not implemented, but that's a potential route. If someone wants to use an Iceberg connector to query a lens table, then that kind of architecture can work. What is kind of well, I'm trying to promote here in this presentation is more of the other route of you can directly use a format native connector to query the data. But the trade-off, I think, is performance versus like things like governance or maintainability, all those kind of things.